In this problem, we're going to go back to the example that we did a few weeks ago, looking at two mechanical aptitude tests. And we want to see if the scores in the two tests are correlated and if this correlation is significant. So we need to go back to our Chapter 6 homework, and that was week 5. And I'm going to copy the data from the two tests there. So Control Copy, and I'm going to go back to our homework here. Control V, and we have the first test and the second test. Let's call it first test and second test. And we want to see if the scores are correlated and if they're significantly correlated. Now they should be, because the people that got the high scores in one should have gotten the high scores in the other, and the people that got the low scores in one should have gotten the low scores in the other. Perhaps not exactly, but in general. Now, to measure to test the significance of R, we're going to do linear regression. And now does this table, let's make a one-tailed hypothesis. One-tailed hypothesis. The two test scores are positively correlated. Now, if we had predicted that they would have been negatively correlated, that still would have been a one-tailed test. If we had just predicted that they were correlated, but we didn't know in what direction, we didn't specify what direction, that would be a two-tailed test. So we're going to go to data analysis, and rather than correlation, which doesn't give us a significance, we're going to use regression. I press OK. Now the Y input range, doesn't really matter which one X and Y is. I'll have the second test be Y. And I'll have the first test be X. And we've got labels at the top. And the output range, I click in the output range box there, and we'll just put it here. And we can press OK. And let's round everything off to the number format. Make it a little bit wider. And so the multiple R, that's what our correlation is. Look at that. This is Control I. This is the absolute value of R. So that's important there. Let's mark that in red. And then we need to know the significance value. Is that significant? And that significance is there. So this is that's very low. P says, or no, the significance is, the P is 0.00. Now it's not really P equals 00. Let's add some more decimal points. Okay, it's really low. So what we're going to do is we can't write P equals 0 because it's never 0, but we're going to write Control I, Control I, P, Control I is less than 0.001. That's the convention for really low P values. And then the degrees of freedom, that's here. So the degrees of freedom are 8. And this coefficient there is the sine of R. Let's see this in red also. Sine of R is positive. It's the same sign as the coefficient there. So what are we going to conclude? We are going to conclude our hypothesis was supported because P is less than 0.05. There is a positive significant correlation between the two test scores, and we're going to put R, so control I, R, control I, and then parentheses the degrees of freedom, which are 8. R equals space 0.98, and then we're going to put that control IP, control I space equals or is less than 0.001, period. So our hypothesis was supported that they're related. They're very strongly related. They're 0.98. That is super strongly related. That's almost exactly the same test. Actually, was it the same test just administered 2 times? I think maybe that's what it was. Oh, yep, it was. Two administrations of the test, spaced 1 month apart, were given to 10 students. So people had the same skills there. So it was measuring the exact same thing. And this correlation 0.98 is significant and with a p-value of less than 0.001.